Okay, first law of thermodynamics. First law of thermodynamics is the restatement of the law of conservation of energy. According to the law of conservation of energy, energy is neither created nor destroyed. Rather, it transferred from one form of energy to another form of energy. For example, it is possible to convert one form of energy to potential energy or vice versa, or one form of energy to another form of energy. But it is impossible to create new form of energy or destroy the previously existed type of energy. Rather, it is transform one form of energy into another form of energy. For example, electrical energy converted or transmitted to transformed to heat energy and light energy, but impossible to destroy. So the first law of thermodynamics is the restatement of the law of conservation of energy, because in this law states that the energy given to one system is equal to the sum of the internal energy of the given system and the work done on the system or by the system. This means if this is the system and here the surrounding, our system, or this is a container, inside the container the gas molecule exists. If some amount of energy is given to this system, let's say the energy given to this system is delta Q. Change in heat, Q is symbol for heat, energy given to this system, heat flows to the given system is delta Q, change in Q is equals to change in internal energy, that is symbolized by delta U. Internal energy is the total energy of one system. U is the total energy of one system. This energy, total energy of one system, is due to the kinetic energy of the molecule of the gas and the potential energy, if potential energy exists, plus delta work done, delta of work done, change in work done. This work done is due to force experienced on the piston. This is the piston of the container. Let's say this is force. If force is applied on the piston may move down and the gas molecule may be compressed. Due to this, some amount of energy is added to the system. Therefore, work is energy that is added to one system due to force. It is energy that is added to one system due to force. Therefore, the heat flow to this system that is symbolized by delta Q is equals to the total internal energy of the system that is symbolized by delta U plus the work done on the system or by the system, delta W. From here, you know that mechanical work done is equals to force times displacement. Let's say displacement is X. If the piston is pushed down by a force F, let's say the final position of the piston is X. Xi is initial position here. After the force F is applied on the piston downward, if the final position of the piston is here, no gas molecule here, the gas molecule is compressed down, and finally, if the piston is here, move down, change in work done is equals to F times change in X. Constant force is applied on the piston, and the piston moves down from position xi, displacement xi to x. There exists change in position. So, due to change in position, change in work done exists. Therefore, change in work done is equals to change force times change in displacement. But pressure is equals to force over area. From this, we have force is equals to pressure times area. Pressure times area can be substituted here instead of force because they are equal. Delta of work done is equals to pressure times area times delta x, change in displacement. Area times change in displacement is change in volume. Change in volume. Therefore, change in work done is equals to pressure times change in volume. Therefore, the work done on this system is equal to pressure times the change in volume of the gas molecules. The pressure experienced on the system times the change in volume on the system of the gas molecule is equal to the work done. Therefore, substitute this expression instead of delta of work done. So, the first expression, famous expression of first law of thermodynamics can be rewritten as heat running to one system, delta Q is equals to delta of U plus pressure times delta of V. This is the famous expression of first law of thermodynamics. The work done can be negative or positive depending on the work done can be done on the system or by the system. This means here, if a force is applied on the piston downward and the gas molecule is compressed, now some amount of energy is added to the system. The gas is compressed and the kinetic high collision is formed between the molecule of the gas. Since high collision is formed and the speed of the molecule is increasing, the kinetic energy of the gas molecule is increased. Some amount of energy is added to the system when work is done by the surrounding or the environment on the system just like this. At this time, work done considered as positive. But if the gas is expanding and the piston is moving upward, the gas is expanding and the piston is moving upward, if it is here, finally, if it is here, the final position of the piston is here, work is done by the system on the surrounding. By the system on the surrounding. The gas is expanding, the gas molecule is expanding. At that time, the collision between the molecule of the gas is lower when it's compared within where the piston is placed here. Because of this, some amount of energy is lost from the system. Because of this, when work is done by the system on the surrounding, by the system on the surrounding, delta of work done is considered as negative. On the system by the surrounding, it is positive. Delta Q, heat, if it is heat flow towards the system, it is considered as positive. If it flows from the system outward, it is considered as negative. Internal energy. If the initial internal energy of the system, one system is greater than the final internal energy of one system, the internal energy of the system becomes negative. But if final internal energy is greater than initial internal energy, this implies as delta U is positive. But if the vice versa of this means if final internal energy is less than initial internal energy, delta of U is considered as negative. Generally, in this video, we have seen about first law of thermodynamics. First law of thermodynamics is the restatement of the law of conservation of energy. Under first law of thermodynamics, the energy flows to one system is equal to the sum of the internal energy of that system and the work done on the system or by the system.